All right, thank you. We have Juan Stoica, faculty at UC Berkeley, advisor to many in the audience and many of the famous people that we've had pass through the VIP lounge in the last 2 days. Co-founder of Databricks, co-founder of Anyscale, co-creator of Apache Spark, of Apache Ray, working closely with the Ella Marina team, advisor to creators of LMSys, which led to Vicuna and Chatterina and SG Lang. So the long list of accomplishments. Often people think of you as the most impactful researcher in systems and AI or AI systems these days. So that's Juan Stoica, also one of my unofficial co-advisors at Berkeley. So I have a bias here. Where should we start? I think two things I want to talk about. You want to talk about evolutionary systems or evolutionary techniques, evolutionary algorithms?
One of them.
Let's hear it. What are these evolutionary algorithms?
You can start with anything you want.
I want to start with that one.
I think, there are a bunch of papers and work, and I think one particular one was Alpha Evolve. It's an Alpha Star paper. And it came earlier this year. And what they show that they use this to solve a pretty impressive set of problems, and both algorithmical and both systems, like improving some scheduling algorithms. I'm not sure if Borg or something like that, and 1%, 2%, whatever. But it's impressive because it's doing something, useful for what we've been doing, Andy, at Berkeley. Remember?
Systems research.
System research. Remember our Mesos?
I haven't forgot it. Deep scars. I mean, wonderful memories.
So actually over summer, many people in the audience, there was an open source version of it called Open Evolve. And we tried in a seminar, we had it in the seminar, and we ran it a seminar to try it. And people for their research.
So one whole
projects.
PhD seminar where different PhD students were trying Alpha
it's like,
Evolve, Open Evolve.
These meetings, like weekly meetings. And different people try on their projects, right?
It's like a parameter optimization technique using evolutionary methods?
It's not parameter optimization. So it's not parameter optimization. It's basically is going to change the code, right?
So updates code using evolutionary techniques.
To improve the performance.
Does it use generative AI also?
It's using, obviously, like language models, right? So basically the one way is working, you have a simulator code, you give the code, you say what you want to happen, you say which code is implementing what you want to change, for instance, load balancers or routing or whatever. And then you are going to iterate on that. You are going to get a solution. You are going to use a simulator to run on a bunch of benchmarks to evaluate it. And the LLM will look at the results. You tell what good results are, what you want to optimize. And then you iterate by reusing some of the old solutions and always generating, hopefully, a new solutions iteratively.
So you ask the model to improve the code in a given way. You kind of give it some instructions. You see if it improved it with some evaluation.
How do you do the research, right? We do the research, and
the way PhD students do research. It's like iteratively,
right? It's like this is exactly try to emulate, right? You want to improve some system performance, and typically you can do either in the real system, but that sometimes is too expensive. So you have a simulator. If there is no simulator, you write a simulator.
I remember writing those.
You remember, right? And then now you are going to start to apply your ideas, to implement in the simulator, different algorithms, tweaks and so forth. And what do? You have a bunch of traces. You run that simulator on the traces. You look at the results. Good. And if right
better,
directions, so you iterate until you get some good enough results to publish, right? That's what you do.
So you also iterate in something like gradient ascent, and this is just an alternative.
This doesn't change.
It's like an optimization technique where you're iterating to find improvements at each step.
Doesn't change the model.
Without changing the model. Changing
only the code.
Only the source code. So you're iterating on the source
simulator code.
The simulator code.
Which is part of the prompt.
Right, yeah. Which is what the model is generating, and then iterating on the source code using the same prompt each time.
Using the same prompt, or you can change also the prompt, like in JEPA, but in particular, the prompt is going to change by taking into account the previous solutions and their feedback, the feedback on the previous solutions.
I've spoken with Laksha and Dilara about JEPA and all their optimizers. So that's another area in which evolutionary technique is showing up. But now it seems like there's this category that you're thinking about, and this
there are multiple alpha evolve. JEPA is a little more general. Alpha evolve, or at least open evolve, the way they evolve. Prompt is more structured. It just mostly the prompt evolves by adding new solutions, and that's kind of the way, and it's working. And the point is that what the excitement comes, it's working better than expected.
Okay, wow. And like, just to zoom out a little, it is doing what PhD students do.
It's exactly.
Which is maybe one of the more exciting things. I can't remember, I think you might have told me the seminar was one you already ran or are going to run, was about a variety of AI techniques that researchers might use. How are researchers using AI to do better research? And are there agents or other frameworks that are making progress at doing research themselves? That has come up in a few different ways in my conversations so far. But
totally. So this is exactly
evolutionary technique being one that is working.
One of them.
Showing progress, promise.
Yes.
Were there others that are showing promise that students in
reinforcement learning is always there.
Okay, RL. Okay, yeah. People most
but in
highly
some
voted
sense,
for overhyped.
they are related. But let me tell you what are the exciting things about this one, at least in my opinion. First of all, it seems they're pretty robust. It's like people, at least during the summer, everyone started with different models, different kind of settings, and many of them they got good results. Good results meaning improving the performance of the state of the art or whatever, what the work they are doing in their research. The second thing is pretty cheap.
Cheap?
Yeah, it's only a few tens of dollars.
Tens of dollars?
Yes.
Wow.
And it's pretty fast. It's like we did in general 100 iterations.
100 iterations.
Right?
And you get progress in 100 iterations, which is minutes or hours?
In each iteration you do, depending on the system you are using, you do an inference on the LLM to generate new solution. You have to evaluate it, and then you that's an iteration.
That's like a minute or a few minutes, depending on the evals?
It's probably depends on the simulator, actually. That can be the bottleneck. The other thing is that you can use the largest language models because you don't need to change them, don't need to modify them.
You can use the proprietary, like Gemini 3 or Sonnet or whatever.
Absolutely. And the other one, the solution is interpretable, right? Because you got the solution is a code. You can actually see,
and you have like
if there are new algorithms or something like that, you can see what...
Because the artifact is the code itself and the simulator that's being evolved.
So that's why in some sense there is some similarity with reinforcement learning, right? In both cases you have a model and you have a prompt, right? And you generate a solution. Then you evaluate with reinforcement learning, you do your rollouts, get the trajectory, and use the trajectory with feedback to write rollouts with the rewards in order to update the model. In this case, use the feedback, which is a result on a particular solutions, to update the prompt by maybe incorporating that solution or other solution in the next prompt, right? So in one model, in the other one prompt, probably you can mix them.
But in the open evolve or alpha evolve, it's actually the code, not the prompt, right?
But the code is part of the prompt.
Oh, I see. Got it. Yeah. And versus like JEPA, where the prompt is being updated and may or may not include, it might be code or maybe a more generalized sort of thing.
Yeah, but you can do code as well.
Yeah. Got it. Cool. So it's like RL in that sense that like fits the model, but is an alternative to RL right now.
Yeah,
and has promise, showing a lot of promise.
Yeah. So that's pretty much at the high level what it is.
Do you see this evolving into a more serious research agenda with another lab, or is there a lot of low-hanging fruit to continue to pursue? Kind of obviously from a research perspective.
I think what I really like about this direction is that you try to solve real problems, right? It's like problems, your research. You need. Right. And
so we're actually giving it the problem I care about as a researcher and seeing if it makes progress on what I'm doing research.
Right? It's nice because it's AI systems and so forth. So it solves the system problems, right?
What are examples of the problems the students were giving it? So I was building a cluster scheduler.
Actually, the prompts are, at least with open evolve and so forth, are pretty clear. You just describe the problem. Say, okay, this is a problem and this is a problem.
But what is one of the problems? Like when I was doing my PhD, I was building a cluster scheduler.
One of the problems is this expert parallelism load balancing.
load balancing for GPU clusters.
For experts on the GPUs.
Experts on the GPUs.
Yeah, right.
Running on processes.
A mixture of experts.
CPU.
Models.
Oh, no, okay, yeah. Mixture of experts.
So right. So you want to have a balancing factor, which is good, right? So you have a good load balancing. And because the problem is very dynamic, because the experts, you are going each token in each layer, you can change what experts are going to.
This is for distributed inference, right? That's what you're saying. So you're deciding when you do distributed inference from mixture of experts models,
totally.
You need to schedule more GPUs under some experts if those are getting more utilized dynamically.
If the experts are lightly utilized, you are going to
give them more resources.
More of them on the same GPU. If an expert is very highly utilized, maybe you want to replicate on different GPUs.
Yeah.
Right? So it's
scheduling for resources for inference dynamically based on the workload.
Yeah, mapping, assigning experts to the GPU, and then obviously you have to do the routing. And there are two things which matters. Of course, is how well you load balance, right? Because it's high throughput, you balance better, you are going to have higher throughput, lower cost. And the other thing is how fast you can rebalance. Again, because it's a very dynamic environment. These are two metrics. And for instance, we did that for DeepSeek. And DeepSeek, there is an open source implementation, but we also had access to the proprietary implementation from DeepSeek.
You had access to their proprietary implementation?
Yes, yeah.
Because you're teaming up.
Yeah, I mean, we have, I have a postdoc working at DeepSeek and things like that.
Awesome.
Yeah. And the solution was, right now we can improve both the load balancing factor and dramatically decrease the performance even of the proprietary implementation.
Wow.
By order of magnitude. So
that's order of magnitude improvement.
Yeah. But there are many like transaction scheduling is about this kind of don't be late, for cloud, for executing a job using spot instances to minimize the cost while still meeting a deadline.
Using what kind of instances? Spot instances, like Amazon Marketplace instances
right.
That can be preempted from
So
you.
these are kind of problems.
Classic systems scheduling problems are a great target for this.
It's like 30% we look at the, the papers which were published in this conference, in the system conference, like 30% or more are performance optimizations, right? They're the easiest to publish, actually,
so
right? Because
traditionally at the conferences I published at, systems conferences, we do the boring thing of making systems faster instead of making them smarter.
Yeah.
So we know the big labs. You hear Anthropic, and actually I've heard different stories. All the big labs, sometimes especially Anthropic, focusing on getting coding, AIs that are good at making the next generation of the AI with this kind of singularity hypothesis. This seems like a different type of research where instead of the AI making the next AI, it's the AI making a better system, which is in support of better AI.
It's exactly. So ideally, you want to optimize and maybe even generate the AI stack.
And there's some research out of MIT with Hari Balakrishnan, which is Glia, and a startup
it's
an open source project.
It's the same vein.
Same thing, and they're doing a startup now. You and I both know Hari. Hari's an academic sibling of mine. I think you're close to Hari, like advising around a startup effort and some research doing the same kind of thing, helping scheduling GPUs and. So it seems like a nascent but very promising area of research that I haven't heard anybody else bring up so far at NeurIPS to me.
JEPA.
But that's true. I have, obviously, at the prompt, but I think we've been framing it often in prompt optimization, better together. That's a very specific instance, and I feel like what you're raising with the open and alpha evolve is one step of more generalization. But maybe I was just not hearing Delara and Laksha.
I think the exciting thing is that we are living in the era where we spend a lot of time, people, optimizing systems, the stack for AI, right? This is what happens, right? This is what we're doing. And things are more and more complicated. The hardware, the infrastructure is more complicated. The workloads are more complicated. The pace of change is faster, right? It's like every year you have a new version of GPU, right? And really it's much, much harder to build this kind of stack, right? You don't have time. If you think 20 years ago, the LAMP stack, that was stable for 15 years.
The LAMP stack, like Linux,
right? You have
Apache
Linux,
server,
Apache,
Postgres,
Apache,
PHP. What was the M?
was MySQL, and P is whatever you wanted. It's PHP or Python or whatever. Right? It was PHP originally. Right? But that was pretty stable. And the infrastructure was simple. It's like, it's one one server. Maybe you have multiple servers, but that's kind of simple parallelism, right? Maybe you have, when it comes to data, maybe you have sharding, the most complicated one. Otherwise, was replication.
Yeah. Not to mention there are only 4 letters in that acronym. Or I think that if we were trying to make an acronym of the current stack, it'd be some weird abomination of a word.
Yeah, so I think that's kind of, if you can accelerate that process. And by the way, there you have also it was more modularized, layered, right?
More modularized.
The stack, right?
Yeah.
But now, in order to optimize, it's a lot of want to do cross-layer optimization.
Yeah. So these systems are primed for that. Yeah.
Yeah.
Great.
So when you put all of this together, I mean, again, if you can imagine that if you can build this kind of stacks 10 times faster.
Yeah. Sounds like a good candidate for the next lab that we need to build here at Berkeley after Sky. So speaking of the stack, I've been thinking about what is the stack today. There's pre-training, mid-training, post-training, prompt optimization, inference, distillation, and RL, and sort of post-training. It sounds like what we're talking about now. There is a stack, but we don't talk about it the way we did with LAMP, or even at AMP Lab, we talked about badass stack. We could point at kind of the big data stack. I believe that we need to be talking more about either the ecosystem or the stack, and coming together as an ecosystem to put forward our unified front so that we can actually work at the frontier in the open. So the people are wearing scarves called Open Frontier, and we're going to make an announcement in like an hour or two about what exactly Open Frontier is that people are wearing these scarves about, but it is definitely related to the open source stack in AI right now, of which many of your projects are at the heart, SkyRL being one, VLM and SGLang. I think you get a lot of credit for both of those. At least your lineage does. And that brings me to this question of why would you need the open source ecosystem to step forward and be more unified than historically we've been able to? I talked about this with Yijin yesterday. I think that we're in a point of existential threat to open research in Western democracies and maybe globally. I think that the amount of resources that open research is receiving are 1 to 3 orders of magnitude less than VC-funded research that happens behind closed doors. I think that historically, for every generation of paradigm tech research before AI right now, including the ones that you and I did for big data and public cloud computing, the big labs also continued to publish a lot in the open. Intel Research, Microsoft Research had their doors, Google Research had their doors wide open, and then built Alpha. They built a delta of advantage in proprietary product on top of it. Those labs have shut their doors, by and large. Jeff Dean was just here telling us about really exciting research that Google is still publishing. And he did say that there are lots of core secrets inside Gemini for competitive reasons they're keeping secret. So what do you think? Do you think we're at a point of existential risk for open research in Western democracies, in the United States specifically? And that's important because the United States has been the leader in open frontier research up until now.
Let me answer this question the following way. So AI, no one is ignoring it. Whether there are some people are hating it. Actually, there is a San Francisco Chronicle article today, why we should declare war on AI.
Why we should declare war?
War on AI.
San Francisco Chronicle?
Yeah.
War on AI.
Yeah, war on AI. There are people who are afraid of AI, discuss about AGI. There are people which are excited about AI.
I'm not afraid of AGI, but we were talking earlier about people who are afraid of AGI.
Talking about AGI. Okay, sorry.
I might be afraid. We'd have to start that conversation.
Okay. So you have all of this, right? But no one can ignore it. Now, so it's something very important. Everyone believes that there are also some people which believe that it's hyped.
We had Trevor Darrell and Alyosha on a panel last night, and they definitely think it's overhyped.
But again, a lot of people say this is very important. It's like it's going to change everything, whatever. So if you have something like that, what do you do? Well, what do? You try to put your best minds on it, right? But now, in order to put your best minds on it, you need these minds to cooperate, right? To collaborate. In order for them to collaborate, they need to be able to share the information and work on also shared artifacts, right? And when it comes to shared artifacts, we are talking about, obviously, code is a big part of it.
Well, like we do with the internet, like TCP/IP.
So that's what I want to say. That when there are two examples I can think of. This happened. One is many people say Manhattan Project, and actually there is some Manhattan Project for AI, which kind of it's about.
That we've heard rumors of anyway.
But there is Manhattan. What happened with the Manhattan Project? Like all nuclear scientists, they were taken and they were
abducted from Princeton and Stanford
to New Mexico,
Los Alamos. Yeah, I spent an internship there.
So everyone there collaborated for whatever, 2 years or whatever. And now you think about the internet. It was very different shape, but it's still because it was only one artifact, the internet. Everyone collaborated because of that interface, and it was
shared artifact.
A shared artifact, and it was open and everything. So you have to have something like this.
But the Manhattan Project was not open, but it was there was an intervention that forced a lot of collaboration.
If you have a big problem in the society, right, and you think it's existential, the way you are doing it, you are going to put the best minds working on it.
Yes.
Right?
Yeah. By one means or another.
That's why I wanted to say, actually, to illustrate that in both cases it's common. The efforts are very different. One is totally closed and so forth. But in both cases,
you are going
to have the best people working on the same problem because you think it's existential for humanity or whatever. Society.
And ideally, all of the world's best minds being a key thing, especially if you can get all of the world's best minds. Exactly. And the United States collected them.
The internet was the same, right? The internet was not only US, was also UK and, and many others. Obviously, we'll think about where World Wide Web was invented, like CERN, right? So, but it was always, it's like, how do you get these people collaborate? And the most obvious way today is shared artifacts and open artifacts.
Shared artifacts and open research.
Yeah. So without doing that, it's a big problem.
So we should do that.
Because that's accelerate, right? That's why the collaboration is important.
You've talked about diffusion of innovation is kind of like what the open collaboration, how it works.
Open ways, this like diffusion of
building
innovation.
off each other.
I think about right now is obviously that the best models, open source models are coming from China. And if you look about, the students here, ask them what models they are using.
It's Quinn.
Or if they, okay.
I asked all of them.
Yes. So, that's what they do. And
in China, there's a unprecedented renaissance of contributions to open research right now.
Absolutely.
You see Moonshot publishing papers and DeepSeek publishing mostly blog posts for both about the techniques they're using, detailed white papers.
And the students, I ask the students, where they learn the newest techniques.
And they say papers and blog posts published by Chinese startups. Is that true?
Yeah, well, Alibaba is not a startup, but yeah.
Or Alibaba, Chinese corporate, large Chinese corporations as well. Alibaba, you said, but that's not happening here because enclosed labs were not publishing as much because of the fierce competition between startups.
This change has been dramatic over the past year.
Dramatically changed. It's like the tides have changed over the last year.
Yeah, I think so.
Where in the sense that the closed labs are getting more closed, or that the open is at more peril.
All of the above.
Certainly we were using Llama a year ago, and now we're using Quinn.
Yeah, and then Llama, Llama was a great model last year. Everyone was using Llama.
So we've seeded the number, like the open weight model war so far. We've seeded the top, the number one title and what we're publishing. Who's publishing the best ideas? We're not publishing the most best ideas anymore.
I wouldn't go to that, degree, but I would say that many of the techniques about training, pre-training, and optimization and things like that. I wouldn't go to best idea. I don't know. It's like
maybe not best idea, but the amount of publication happening at least of good, high quality ideas. Who's best, we can leave it at that. So in your opinion, something dramatic needs to happen to. Something unprecedented need to happen to revert this trend for us?
Yeah, what we discussed early on, right? It's like you need to increase diffusion of innovation and the speed of innovation.
So we're going to need more people doing open research. That is one way, it seems. Or we would need a nationalization of the top mines the way they did in the Manhattan Project. That's another way, historically, that you cited.
Very unlikely, but yeah.
It seems harder or less likely to happen. Okay.
And it will be harder to involve people from other countries.
Cool.
So it's the first choice is highly preferable.
And so then just to play it out, if we need the best minds to be working in the open, the reason they're not today, I think I've heard are two reasons. They're not well-funded enough, so they don't feel they can do frontier research. They need a $500 million cluster, and we have a $1 to $5 million cluster on average for these projects. And the amount of pay that they get used to be, you and I have talked about this, when I graduated, maybe when you graduated, staying in academia versus going to industry was about 2x difference, and now it's 10 to 1,000x difference.
That's exactly.
And so those are the two main obstacles. So we'd have to think through, if we were going to get the world's best minds to work on open research, we'd have to think through how to overcome those obstacles.
It's obviously data, but I think we can
access to big data. Maybe money helps us generate data.
I think a lot of other things is about it's also, the image of AI actually in the US is not great.
Yeah. Well, right? The public sentiment about it, very
public
negative
sentiment
right now.
is very negative.
Yeah. Not what happened. That's not true inside this part of San Diego right now or Silicon Valley, but
otherwise it's negative.
Right.
If you look.
Well, how's that weigh in?
Parties.
How does that weigh in to this?
Well, I think that it's always easier to do these things if the sentiment of the population is positive.
And open research, by the nature of open, you're bringing people along more because you're being more transparent about how it's happening. And you might change the tide of sentiment.
But then you still do AI. That's what I'm saying. It will be nice to... And remember that early on, people are against AI, open AI, right? Many high-profile people that, what happens if these models are going to get in the hands of...
Right. Which is why they kind of justified closing their research doors in the first place.
Yes. So you have all this narrative about the AI. And you do open source AI, but it's still going to take the jobs of the people, right? So I think there is a lot of work to be done there as well.
So we need to make safety a primary part of open research in AI if we're going to win this tide shift.
Yeah,
besides needing to raise a lot of resources.
And AI should be one of these technologies raising all the boats. Because it can be safe, but it can still take your job, right?
Okay, yeah, separate things.
And I think, that's kind of what is a worry out there.
Okay, well, I think you and I are on the same page about this. I think we can say stay tuned for... what we'll talk about with Open Frontier announcement in an hour or an hour and a half or something. So thank you, Juan, for joining. And let's give Juan a round of applause.
Thank you.